while the L is the slant height. So we have our slant height, vertical height, and the base radius. The base radius, you know, this bottom, what you have at this bottom is what? Is a circumference. I mean, it's a circle. So this is a cone. So generally, the volume of a cone is similar. The volume of a cone is similar to that of a cylinder. Recall that for a cylinder, your volume of cylinder is what? Pi r square h. Now for your cone, the volume of the cone is equals to 1/3 pi r square h. That is the volume of a cone. 1/3 pi r square h. Recall that of a what? That of a cylinder was what? Or is what? Pi r square h ordinarily. So for a cone, it will now be what? 1/3 pi r square h. So it's that simple. Now, but you should note something. Note that this side labeled L is your slant height. Are you getting me? Is your slant height. So at times you may need to, if you look at it, if we decide to bring it out, if we extrapolate it, are you following me? It means that you can actually use the formula for what? It's giving you what? A right angle triangle. If you extrapolate this, so this will be your H and your L, and this will be your R. So you can use your right angle triangle to get any other information you are not giving. You can use your Pythagoras theorem. Sorry, Pythagoras theorem deals with what? This. So if you are to use Pythagoras, this is going to be what? This is going to be L squared is equal to what? H squared plus R squared. So take note of this. Take note of this. Please, I believe we should be done writing by now. So that is for volume of the cone. So we'll be moving on to surface area of a cone. We have curved surface area and total surface area, just like the way we have it for your for your cylinder. So we have the curved surface area and the what? And the total surface area. I hope I'm allowed to rub off the board.
No.
Okay, let's make it snappy. You can take a screenshot. I've taken the picture of the note already, but I'm not sending it to the group. It will be on your Google Classroom. All right, so the next one is curved surface area of the cone. So the curved surface area is simply given as what? The formula for this is what? Pi r L. That is the formula. It is pi r L. That's the formula for the curved surface area of a cone. pi RL. Where what? Where your R, where R is the base radius, and L is the what? Slant height. And of course, you know what pi is already. So the next thing is our total. Now, please let me explain what curved surface area means. It means that, let me get something to illustrate. Although this is not a cone, but let's just assume it's a cone. A cone is like something like this, like a third of this. I mean, like where you cut this into half. So now, the curved surface area is just talking about the body, the area where you have your curve. Are you following me? This part. It's not taking the base into consideration. The base is not taken into consideration. We are talking about curved surface area. Curved. So only the part that is what? Curved, which is the what? The surface, the body. Are you following me? So now, we now have what we call the total surface area of the cone. Now, in this case, your total surface area, TSA for short, is given as pi R squared plus pi RL. So in short, can be pi R is open bracket what? R plus L. Now in this case, in the case of your total surface area, you are taking both the curve and the base together. You are taking those three into consideration. Are you following me? You are taking both the curve and the what? And the base into consideration. So look at it, you have your curve and of course the base. So that's why you have this pi R square and pi RL there, because of that curve that you are taking into consideration. I hope it's clear, I hope it's understood. So now we can solve questions on it. Let's take a simple question. So they said the base, the base so example 1. They said the base diameter of a right cone. A right cone is still a cone, still a normal cone. It's a cone with uniform cross-section area. So even when you say a right cone, are you following me? They'll tell you that it's a cone with what? A uniform cross-sectional area. Of a right cone is 16 centimeters and its slant height is 12 centimeters. Full stop. Then I said, question A, find the perpendicular height. The perpendicular height of the cone. And B, find the volume. Find the volume of the cone. C, find the curved surface area of the cone. And D, find the total surface area of the cone? Very simple question. This is a 4-in-1 question. It's a 4-in-1 question. So now, what do we do? What do we do? So we run this part off. Now, what you need to do is, since you've been told that it is a cone, are you following me? If I were you, the first thing I'll do is I'll draw out the cone. It's a cone. So let me draw it out. Since the cone. Good. So we have our cone. So now what are the information that we're given? So the information we are given, they said that what? That the cone has a base diameter. A base diameter. So meaning that from here to here, which will be our base diameter, is what? 16 centimeters. And then they said the slant height. Now the slant height is different from the vertical height. It's different from the true height. The slant height is this height you have by the side. So usually we represent that with what? L. With letter L. So our slant height, that is what? 12 centimeters. So this is represented with the letter L. Now, so the question is this: find the true height. Now, what you need to do is, if I were you, record that diameter is equal to, or rather, radius is equal to your diameter divided by 2. So first and foremost, we need to obtain our radius. That's what that means. We need to obtain our radius. So our radius R is equals to D over 2. D represents what? The diameter. So that will be what? 16 divided by what? 2, which is what? 8 centimeters. So now if you look at this very well, that means something that we now have something like this. And this will be 8 centimeters, while this is 12 centimeters. So now, what's the first question? The first question said we should obtain our what? We should find the perpendicular height. So what do we do? We use Pythagoras theorem. By Pythagoras theorem, that will be what? That will be L squared is equals to what? R squared plus what? H squared. Isn't it? Based on the formula you're given. You can check your notes. So this is going to be what? Now, but what we are looking for is H squared. So that will be H squared is equals to L squared minus R squared by using your change of Pareto formula. So this is going to be what? 12 squared minus what? 8 squared, which is 144 minus 64. And of course, 144 minus 64 should give us 80. That should give us 80. So that means H is equals to square root of what? 80. That would be 8.9 to 1 decimal place, 8.9 centimeters. So we've obtained the answer for the first one, which is what? The vertical height. So now we'll try and obtain the answer for the second, which is what? B. Find the volume of the cone. Now recall from the formula we gave to you that the volume of the cone, V, is equals to pi, is equals to 1 over 3 pi r squared h. It's quite similar to that of the cylinder. The only difference is that what? Is that you don't have 1 over 3 there. So this is going to be 1 over 3 multiplied by our pi is 22 over 7. So that is 22 over 7 multiplied by our r, which is 8 squared times what? Our height, which is what? 8.9. We just obtained that. Recall. So by the time you multiply everything, you're going to get 599.51 centimeters cubed. Recall, remember that for your volume, whenever you are solving a question that involves volume, you use what? The Q as the what? As the units. The unit Q. So the next part of the question, you are being asked to look for what? The total surface, the curved surface area, pardon me. The curved surface area. So if you have to obtain the curved surface area, CSA for short, recall that the formula for that is pi RL. So this will give us what? 22/7 multiplied by R. What is R? What is the value of R? The value of R. Okay, we are given R to be 8. So that will be 8 multiplied by our L, which we are given to be 12. So by the time we multiply that through, so that will give us 301.7 centimeters square. Remember, you're looking for area. That is why you're using centimeters square. For volume, we use centimeters cube. For area, curved surface area, that is centimeter square. And then the next question, which is the last question, they said, find the total surface area. Your total surface area, TSA, is equal to, the total surface area, TSA, is equals to pi R square plus pi RL, which is what? Pi open bracket R plus what? L. So what's our pi? 22/7 multiplied by our R, which is where's our R? 8. Thank you. This will be what? 8 plus 12. So this is going to give us 22/7 multiplied by 8 multiplied by 20. And our answer would be this will be 502.9 centimeters squared. It's also going to be centimeters squared. So that is that on that. Let's write. So now I'm going to give you a question that has a combination. All right, so this next question has a combination of both cylinder and cone. A combination of a cylinder and a cone. So let's see how you solve that. So we have this shape. We have this shape below. So example 2. So from what we can see here, you would notice that you have, this is what we call a composite shape. Now, what do I mean by composite shape? You have two regular shapes combined together. Now, in this case, you have your cylinder here, and then you have a cone here. I hope you can see that. You have a cylinder being combined with what? With a cone. Cylinder bottom, cone at the top. Now, what's the question? Yeah, asked to calculate two things. Alphabet A, they said calculate the total surface area. And B, they said calculate the volume of the shape. The volume of the shape. Remember in previous classes, I explained what volume of the shape means and what, when you say volume, volume is what the shape can contain. If you have a bucket, the amount of water the bucket can contain will be the volume. If you're talking about area, we're talking about the surface, the extent, the physical structure, the extent of the physical structure. But the volume is what it can contain, what it can accept, what it can take in. So now let's try and solve this question. It's quite simple. Now, but this is where it takes deductive reasoning. Now remember that I said you should calculate the total surface area of the shape. Of the shape above. Now, but if you look at this very well, you have your cone here and you have your cylinder. Now remember that your total surface area, if you are looking at the cylinder, let me try and get this cylinder. This is your cylinder. Are you following me? But for your total surface area, you know, that means we'll take this bottom part into consideration. We take this curved side into consideration, and then we take this top side into consideration for us to get our total surface area of the what? Of the shape. Now, normally, PSA of a cylinder is equals to what? Is equals to, let me adjust the camera. Is equals to what? 2 pi r squared plus 2 pi r h. That's the total surface area of a cylinder. However, the reason you have 2 pi r squared is because you have pi r squared up here and pi r squared down here, which is area of this circle and area of this bottom circle. Are you following? But for your total surface area, if you look at it, you won't be needing this. I don't know if you guys what I'm saying. You only need this circle. You will not need this circle because you cannot see it. It's not part of the what? It's not part of the surface area that you can see. And if this cone was not there, what would happen? You'll be able to see up here, right? If, for instance, this cone was not here, you will see this top and this bottom. But because this cone is here, you cannot see it. You're only seeing it because we drew it here. Are you following me? But in reality, you cannot see this shape because everywhere will be, will be covered. So that means for this particular question, you are only going to take pi r square, not 2 pi r square. It will be pi r square, which is the area of this circle, plus 2 pi r h. That's what you will take. That is the reality of this question. Are you following me? Ordinarily, total surface area of a cylinder is this. But because of the peculiarity of this question, you will not take these two. Instead, you are only using one of the pi r square. So this is TSA of the what? Of the cylinder here. So I'm going to rub this off to avoid confusion. Are you following me? Of one base circle. Let me use this so that in case somebody else sees it and doesn't understand what we explain. Of one base circle. Now, then you now look at your cone. If you look at this cone, you will notice something too. You notice something about this cone. You know that ordinarily too, if this were to be the cone, and they ask you for the total surface area, that means you will take this into consideration and take the bottom into consideration. But in this case too, you know you cannot see this bottom. What you can only see is this curved side of the cone. I don't know if I'm making sense to you. It's only the curved side of the cone you can see. So meaning that you would also have to only take the what? The area of cone, which is only showing you what? With no base. So of course, if you have a total surface area of a cone with no base, then that means, normally it is pi r squared, which is supposed to be the area of the base of the circle, plus the pi r l, which is the what? The curved side. But because you are not seeing that circle, I don't know. So that means this part is not there. It's cancelled out. So you only have what? Pi r l. So now, to the question you asked, find the total surface area. Find the total surface area of the shape. Total surface area of the shape. So of course, this is going to be what? This is going to be pi r squared plus 2 pi r h, which takes care of the cylinder part, plus pi r l, which takes care of the what? Of the cone part. Now, I didn't give us a value for this. So this, please come back to this question. This radius is 6 centimeters. This height that we have here, this height, which is for our, is 10 centimeters. And then you are given this. You are giving this to be 10 centimeters. You are giving that to be 10 centimeters. So I believe we now know what to do with this information. So of course, our pi is 22 over 7. Okay, let's assume we're told to take pi to be, okay, 22 over 7. So this is 22 over 7 multiplied by our base radius, which is 6 squared, plus 2 times 22 over 7. Our base radius, which is 6, multiplied by the height, which is 10 centimeters, plus 22 over 7, plus 22 over 7, multiplied by 6, multiplied by our slant height, yeah, our slant height, which is 10 centimeters. So let's calculate and give the answer. Do we have an answer? Hello? Hello? Matt? Okay. The thing is, okay, come up. If you don't like playing later, come up or no? Come up or no? C'est problème. Come up or no? Do you have an answer yet? We have less than 6 minutes to complete the class. Okay, so this is 113.14 plus. This is 377.14 plus. This is 188.57. So if we add everything up, this is going to be 113.14 plus 377.14 plus 188.57. That'll be 678.85 centimeters squared. Now, for the final part of the question, we are asked, this is A. We are asked to what? Also calculate the volume of the shape. Now, volume of the shape is not affected by all what we discussed before. The volume of the shape is not affected by all what we discussed before. Because whether we like it or not, this will contain what it will contain, and this will also contain what it will contain. So it has nothing to do with whether we are looking at the base area or whether we want to ignore the base of one part or not. It's just what it can contain, what is inside. So that means the volume of the shape is going to be volume of cone plus volume of cylinder. That's just it. And what's the formula for volume of cone? That is what? 1/3 pi r squared h plus what's the volume of a cylinder? That is what? Pi r squared h. Good. So this is going to give us 1/3 multiplied by 1/3 multiplied by 22/7 multiplied by r, which is 6 squared, multiplied by h, which is 10, plus our h for cone is not 10. It's not 10 for the cone, because that will be the vertical height of the cone, which we've not obtained yet. So to obtain the vertical height of the cone, vertical height of cone, this will be what? So here, this is 22/7 times 6 squared times 10. So the vertical height of the cone, using our Pythagoras theorem, by Pythagoras, that will be h squared is equals to 10 squared minus 6 squared. So this would be 100 minus 36. So h squared. So h will be equals to what? 100 minus 36, that is 64. So h is equals to what? 8 centimeters, because both sides, 8 centimeters. So that means the height for the cone here is 8 centimeters. So please, this is it here, 8 centimeters. So you have to be very careful. You can see we almost made an error. So that will be 8 centimeters here, because we use Pythagoras theorem. Remember that we are not using slat height for that part of the question. So that's why. So this is 8 here. Please let me write it well. 8. So if we calculate everything together now, So this is 2112 plus this is 7. Okay, no, divided by 7. This is 1.
So I cannot see the board.
Okay, just 113.43. This is This is 301.71. So if you add them up, if you add this and this up,
400 and
1,430.